Welcome to another Unnecessary Computer Things. Today we're going to look at converting the Leapfrogs game from the last episode from Sinclair Basic to VIC-20 Basic. Starting out, I want to note that I made an attempt to not change syntax if it was legal and the logic worked for the new platform. I will slightly deviate from this when I tweak the game end logic. Let's start by running the original ZX80 program. We immediately get a syntax error in line 300 because Commodore VIC-20 Basic doesn't have an explicit screen clear statement. But we can substitute by printing the clear character represented in quotes by this reverse heart. Next, we need to choose printable characters for the Leapfrogs initialized to the PETSCII values of a heart and spade instead of, in the Sinclair version, a reverse quote and a reverse space. Okay, on line 360, we're printing out numbers, but in Commodore Basic, numbers are padded with a character up front for a possible minus sign and then back to avoid the number running into characters immediately after it. We can substitute in the PETSCII value for 0, 48, and then add the digit we wish to print to get a single character and pad a space manually. Notice now how we're a character short above the 5. That's because P5 is 0, which is non-printable. Let's change that to the PETSCII value for a space, 32. Okay, in the ZX80, there are 32 characters across for the screen. The VIC-20 only has 23, so there's not enough space for the intermove. Let's add a print on a line 490 before it. So we're inserting just a straight up print there. Okay, now we can try our first move. On the ZX80, 45 becomes 4 to 5. On the VIC-20, we immediately get a repeat to the input question mark, indicating that our input was rejected. Why is that? Let's look at line 530 now. So our input of 45 would mean that print 45 divided by 10 from that F would be 4.5. VIC-20 basic will return a float for 45 divided by 5 versus a 4 for ZX80 basic. Let's force that result to an integer. While we're at it, let's look at the rest of the move logic. Okay, so line 550 and 580 are looking for a 0, but our empty slot value is now 32 because it's a space. So we need to check for equal to 32 on line 550 and greater than 32 in our T2 slot instead of 0. Not equal to would work as well on line 580. So 32 here, enter. 32 here, enter. Also, the PF, which is the from storage space left behind by the move, needs to be 32 now. Okay. Now we need to check the end game logic. In our original program, X is being used to track if there are any conditions to continue the game. We can remove this since line 570 is also depending on a value, 750 is also depending on a value of 0 for the empty slot as a shortcut. So we'll just remove that. And then we'll look for a space in P5 on line 760. So if it's not equal to 32, so if P5 is not equal to 32, then continue. So the space has to be in the middle. Okay, now we need to rewrite the logic for 730. For the ZX80, the logic is relying on both the two Leapfrog characters being 128 and 129, which is one number apart, and then the Boolean tree returning -1, which makes this I greater than 5 work. That works for Commodore Basic to some degree, but our characters are different, and we need to do some more arithmetic. So I'm opting for a Boolean and or on line 730 and looking for the heart and spade values in their original slots as a sign to continue the game. And I'm going to just copy and paste this one in because it's a little bit messy. So if I is greater than 5 and you have spades, or I is less than 5 and you have hearts, then keep going with the game because you're not done. And then finally, our exit the game logic. There's no code keyword in VIC-20 Basic but we can check that the leftmost character is a Y instead. So left a string 1 equals Y, and then go to 200. All right, finally, we should be able to run the game. All right, that's it. Thanks for watching. Please comment with any ideas of future episodes and like and subscribe. Thanks.